to another episode of THP Tutorials. In this video, we'll be looking at operations management, reliability and maintenance. We'll be looking at providing redundancy in series. So here is a typical setup in series, and redundancies have been provided for R1 and R2. Right, now the general formula for system reliability is RS is equal to R1 times R2 times Rn, where n is the number of components in the system or in the setup. Right, now before we can use this formula, we must compute the redundancy where it has been provided. Right, we have to solve and get the system reliability for R1, do the same for R2. Then when we are done, we multiply R1, R2 and R3. So let's begin. Now, how do we find for the system reliability of this, like this part? Like, how do you do that? So we use this formula, right? This is the first component, this is the second component. So RS, or system reliability, is given by the probability of the first component working, this is the first component working, plus the product of the second component working, the probability of the second component working, and the probability of needing a second component. Now, the probability of needing a second component is the same as the probability of the first component failing. Right? So, if that's the case, the probability of the first component failing will be given by 1 minus the probability of the first component working. Right, so let's begin. First, we'll solve for R1. Right, so that gives us Rs is equal to probability of the first component working. That's 0.9. This is the first component, this is the second. Right. So that's going to be 0.90, the same thing, plus the probability of the second component working. That's what? 0.9 as well. Times the probability of the second component of needing the second component, right? So that's going to be 1 minus the probability of the first component working, which is 0.9, right? So when you calculate this, use that. Right, and computing that also gives us this answer. So R1 will be equal to 0.99.
Okay.
0.99. Now we do the same for the second part, right? This is 0.8, 0.8. First component, second component, right? So we use the same formula. Right, so the probability of the first component working is 0.8 plus the second component is what? 0.80 multiplied by the probability of needing the second component. Once again, which is what? 1 minus the probability of the first component working. So that becomes 1 minus 0.80 as well.
I don't know that this nice my food. It's I mean, mo kaya mo na mo ya go.
Mo yan yung mga ang bisa mo i-ship. Alpha.
Spec. Mas ko ga no.
Pwede.
Why the best car?
Hindi ang praso mo bisa.
Slow. That's Francis coming.
Exactly. So now for the R3 there was no redundancy provided. There was no backup, right? So the reliability is 0.9. So now we just use this formula, the RS formula. This, then get our answer. So again, RS is equal to 0.99 times 0.96 times 0.99. This is 99 rather. So RS becomes 0.94. Convert to percentage. Right. So there you go. This is how you solve for redundancy, in the series. After next, we look at parallel redundancy. Video is covering providing parallel redundancy and maintenance and reliability. Right. So here you have the typical setup. There's parallel redundancy here. This is referred to as the top part. This is the bottom part. Right. So how do we go about computing RS? This goes a little different from the usual, right? So first you have to find for the reliability of each of these parts. So you find for the reliability of the top part, you do the same for the bottom. Now for the top part, it's only one component that's over there, so we just use that one. So R1 is we don't need to compute it again, right? But for the bottom part, there's that's R2 times R3. So to find for the reliability, the total reliability of the bottom part, we'll use the RS formula, the general formula, which will give us R2 times R3, right? Now R2 is 0.9, right? And R2 is 0.98. When you compute that, that will give us this 0.882. So now what's next? Calculating for reliability in the parallel redundancy is a bit different. right? So what we do in this is we calculate the probability of this component failing or the top part failing, and we also calculate the probability of the bottom part failing, and we subtract that from 1 to get the probability of the whole setup working, right? So in this system, this parallel redundancy, RS is given by 1 minus the probability of all component failings. Right. Now, a good question to ask would be, how do we find the probability of all components failing? Right. So, the P of all components failing is going to give will be given by so something like this: probability of first component failing times probability of the second component failing, right? So it's just the product of all the components, the product of the probabilities of all the components failing. I'll explain that more in details, right? So how do we get for the individual one? That's simply going to be given by the probability of the first component failing, given at 1 minus the probability of the first component working. So how do we go about it over here? Let's take a look at that. So for the top part, let's do the top part first. Alright, so let's say probability of top part, let's do this TP. Talk about our space. TP failing will be given by 1 minus the probability of the top part working, right? This is R1. So the probability of the top part working is equal to R1, right? Which in turn is equal to 0.95. See? So this becomes 1 minus 0.95. That is 0.05. Right, 0.05. So I'm going to put that down over here. So the probability of the top part failing is equal to 0.05. Now we do same for the bottom part. The bottom part. So that's just BP, right? So the same formula. Then just conserve the space and save time. Right, so right? So this is BP, right? This is a probability of bottom part working the same as the reliability of the bottom part. So that becomes 1 minus 0.882. So 0.118. So let's put that over here as well. So now the probability of bottom part failing becomes now the probability of the entire system failing, like this whole system, will be the product of this and this. So let's calculate that. Right, so that's for parallel redundancy. R is given by 1 minus probability of all components failing. Right. Now to get this probability of all components failing, I'm just going to do this ACF, right? That gives us the probability of top part failing times the probability of the bottom part failing. Yeah. 0.05 times 0.118. Right. So this is giving me another in standard form. So 1 second. 1, 2, 3. So 0. Yeah, 0.059. No, this is 0.0. The probability of all components failing is given by 0.0059. Right? So 1 minus this gives us the reliability of the system. So RS is equal to 1 minus 0.0059. So 1 minus 0.0059. This becomes 0.9941. Right? So converting our answer to a percentage will give us 99.41%. So there you go. Yes, so that's it for this video. Thank you very much for watching. Please don't forget to like and subscribe.